All right, hey guys, we are going to go over lesson 10.3, which is all talking about theoretical probability, which I've talked about a little already, so this shouldn't be too bad. You need to have your math book out and a calculator as you watch this, and you should be taking notes as you go. Our learning intention for today is we're going to be able to find the theoretical probability of a simple event and its complement, and we'll talk about what that is. Okay, so open your math book to page 529 if you haven't. So we have already talked about theoretical probability, but first we're going to talk about something called a sample space, and we'll take good notes on this later as well. But a sample space, all a sample space is basically a list of all the different things that you could get, all the different outcomes. So if I rolled a dice, I could get a 1, I could get a 2, a 3, a 4, a 5, and 6. This is called a sample space. It's basically just what you can get when you're doing it. If I flip a coin, my sample space is a heads or a tails. That's all I can get. If I spin a spinner that has an A, a B, a C, and a D on it, my sample space is A, B, C, and D. That's what a sample space is. All right, if you look on page 529, just another something to talk about. So when we're talking about with probability, and I want to know what my sample space is for rolling a dice, it's always 1 through 6 if I ask you the sample space. But if I ask you, hey, what's the relative frequency when I actually did roll a dice? Okay, what was my chances of getting a 1? Well, I got it 0 out of 6 times, which is 0 or 0%. That's the experimental or relative frequency. Okay, that's what actually happened. Theoretical is like what should happen. Well, I should have got 1 out of 6 times. I didn't, but that's theoretical. And then also, again, the sample space is still the numbers 1 through 6. Because that's what you could get. Those are the possible outcomes. All right, so then if I ask you, they put the letters, all of these letters written on a piece of paper and placed in a bag, and they draw a letter at random. The sample space is all the different unique possible outcomes. So even though some letters repeat, the outcomes in the sample space are unique letters that appear in the word. So what that means is if I ask you the sample space, I could get an M. I only need to list that once. I can get an A. I only need to list that once. I can get a T. I can get an I. I can get a C. I can get an S and an H and an E. That is my sample space. You only have to list each letter one time for your sample space. All right, so 5:30, let's try the check. Go ahead, read through it, and you write down what you think is the sample space. All right, so there are 5 students with blue eyes, there are some hazel eyes, and some green eyes. I just need to list blue, green, and hazel. I don't need to list blue 5 times or hazel 5 times. So you just need blue, green, and hazel, which is letter C. Doesn't matter the order either. All right, if we go to page 531, again, I've already talked about theoretical probability. It's what should happen. And we've done this. We already have this in our notebook, so we should be good with that as well. Okay, so it says, suppose you tossed a coin 20 times and recorded the results as shown. You got 3 tails and 17 heads. So the experimental or relative frequency of getting a heads is 17 out of 20 times because I did it 20 total times. Tails is 3 out of 20. Okay, that's what actually happened. That's called the relative or the experimental, we call it as well. Theoretical is what should happen. So it should have been half the time I should have got heads, half the time I should have got tails. That clearly did not happen, but theoretical is what you expect to happen. So if we go to page 532, it says I have 8 discs that are marked 3, 4, 5, 6, 7, 8, 9, and 10. And it just has one number on each disc. It says a disc is selected at random. What is the theoretical probability of selecting a disc marked with a prime number on it? Ooh, so first of all, we need to actually know what a prime number is. So prime numbers are numbers that nothing goes into it except 1 in itself. So like nothing goes into 3 except 1 and 3. Nothing goes into 5 except 1 and 5. Nothing goes into 7 except 1 and 7. All the rest of the numbers, other things go into, like 2 goes into 4, 3 goes into 6, 4 goes in there, 3 goes in there, 5 goes in there. So there's only 3 prime numbers. So the chance of getting a prime number is 3 out of there's 8 total things in there. That's the theoretical probability. Now, if I ask you to change that to a decimal, you guys know you do 3 divided by 8, which is 0.375. And then if I ask you to change that to a percent, times it by 100, you get 37.5%. So this is all theoretical probability. It's what should happen. All right, go ahead and try the check on page 532. So I have a number dice labeled 1 through 6. What's the theoretical probability of rolling a number less than 6? And write it in simplest form. So the numbers less than 6 are 1, 2, 3, 4, and 5. That's 5 numbers out of 6. So that is my answer, letter D. All right, the next thing we're going to talk about is on page 533. I'm going to try to talk about this the best that I can. So let's say that I'm spinning this spinner, okay? And I'm just going to put some things on it. I've got an A, a B, a C, and a D on my spinner. Okay, so I might ask you, hey, what's the probability of getting an A on this spinner? Well, you'd say, hey, it's 1 out of 4. Okay, that's the probability of getting an A. That's when I would be successful. That's called a success. Now, I might also ask you, what's the probability of not getting an A then? Well, that would be 3 out of 4. That would be what is not a success in that case, okay, because I wanted an A. These two events, these are called complements. So complementary events are two events that can't happen at the same time. It's kind of like the opposite. So if I wanted an A, the complement of that is not getting an A. Okay, there's a couple ways that you can write that. One way to write that is I could say, hey, what's the probability of getting an A? The complement of that is what's the probability? You can write it like this. That means not getting an A. Okay, notice if you add these up, if you add these two fractions together, a fourth plus 3/4, that's 4/4 or 1. So they always equal 1 when you add it up together because that equals kind of like the whole thing. So that's what complementary events are. So if I say, hey, I want to get an A, that's a successful event. The complement of that is not getting an A. And it has to equal 1 when you put those together. All right, so if you look at page 533, I'll kind of explain it a little bit more. So it says you roll a number cube. Your desired outcome is 3. That's what you want to get. So I would say, hey, the probability of getting a 3 is there's 1 out of 6 chance. That's a theoretical probability. Okay, the complement of this event is not getting a 3. That's called the complement. So not getting a 3, I have a 5 out of 6 chance. Okay, so every other number except a 3. Again, those two have to add up to 1. If you add 1 6 plus 5 6, that's 6 6, which is the same as 1. So let's look at another one. So I have a spinner. It's divided into 8 equal sections, numbered 1 through 8. All right, and I might say, okay, the desired outcome is an even number. I want to get an even number. So the probability of getting an even number is 4 out of 8. The probability of not getting an even, that's the complement, is also 4 out of 8, all the odd numbers. Okay, if I add those up, I get 8/8, which is the same as 1. So again, this is the event, the desired event that I want to happen, the desired outcome, and this is the complement, like the opposite of what you want to happen. So if we look at page 534, let's try one. Raphael is going to ride a roller coaster, chosen at random, and wants to find the probability of choosing a roller coaster with a height of less than 250 feet. It says, what is the probability of the complement of the event? Okay, so if we start with all the ones that are a height of less than 250, let's go ahead and circle those. So here's a height of less than 250. That's less than 250. That's less than 250. Okay, so the ones that are less than 250, there's 3 out of 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that is the probability of getting one less than 250. Now, that's not what the question asked, though. It wants the complement of that. Well, the complement is everything else, so that's everything that's left. So there's 1, 2, 3, 4, 5 left. I could have just figured that out, too. That would be the probability of the complement of the event. So these would be all ones that are more than 250 then. So that would be my solution. All right, let's try the check on page 534. Why don't you pause and try this one? So a bag contains 25 marbles. 10 of them are red. The other marbles are blue or green. A marble is selected at random. What's the probability of drawing a marble that is not red? Okay, so this one actually isn't too bad. It doesn't even ask you for the complement. So not red. Well, if 10 are red and there's 25 total, that means there's 15 left that are not red. So that means my probability of not getting a red is 15 out of 25. Now I'm going to try to simplify that. Let's divide it down by 5. If I do that, I get 3/5. Okay, now let's just quick practice. Can you change that to a decimal and a percent? All right, so to do that, I'm going to do 3 divided by 5. That's going to give me my decimal, which is 0.6. And then times that by 100 to get my percent, which is 60%. So my probability of not getting a red is 60%, or 3/5. All right, we have 2 more quick problems. So it says, hey, I've got a spinner here. You guys can see the numbers. It's labeled 1 through 8, and I'm going to spin it 600 times. Okay, so I'm going to underline that, 600 times. I want to know how many spins of a number less than 4 can be expected. Okay, so let's look at the numbers. Less than 4. Less than 4 would be 1, 2, and 3. There's 3 out of 8 total. That's the probability of getting a number less than 4. But I do this 600 times. So not 3 out of 8. I want to know how many out of 600. So there's 2 ways you can do it. One way, you can set up a proportion. So 3 out of 8 chances, I want to know how many out of 600. So if you do it that way, I'm going to do 3 times 600 and then divided by 8, and I end up with 225. Now, another way to do it is I can say, hey, 3 out of 8, what percent is that? Well, if I divide 3 by 8, it's 0.375, or 37.5%. So that means out of 600 times, I'm going to get a number less than 3, 37.5% of the time. So I can do 600 times 0.375 as the decimal, and if I do that, I end up also with 225. All right, last one is the check on page 536. Why don't you guys go ahead and try it? It says a number cube labeled 1 through 6 is rolled 1,200 times. How many times can it be expected to roll a multiple of 3? All right, well, multiples of 3 are like 3, 6, 9, 12. On a dice, it only goes up to 6, though, so there's 2 multiples of 3. So that means I have a 2 in 6 chance. Okay, it says, hey, but I roll it 1,200 times. So not out of 6, I'm going to roll it 1,200 times. How many times do I expect to get it? So this is one way you can do it. So I'm going to do 2 times 1,200. And then divide by 6. And I end up with about 400 times. The other way you can do it is you can do 2 divided by 6, which is like 0.3 repeating, and then times it by 1,200. And you should still get, if you type in times 0.33333, you still get 400 times. All right, so the learning goal for today is, can you find theoretical probability? Can you find a sample space? And can you find the complement of an event? So hopefully you can. So you're going to attempt the May 10th class kick now. It will be due on Friday. So if you have questions, you can ask me tomorrow. So you have the rest of the time to work on that.